We'll move on to the liquid side streams. Yeah. And before we go on to liquid side stream, I'll just quickly recap what we did in a previous one was on solid side stream. You saw the example from shrimp shells. Yeah. So recap, we take it with the crab shell. So similar story with the crabs. Yeah. Shrimp and a crab. How many of you know what is a crab? Kekada. Yeah. So there are a number of different types of crabs are there, right? Blue crab, spider crab, number of different types of crabs of different sizes. So again, if you'll see, normally it's primary process, final product for direct commercial sale. This is one way it is sold directly. After cleaning and killing, or sometimes live crabs are sold, yeah? In certain countries, and live crabs are cooked live, yeah? Like what it happens in Nurk, you know, you have to fry, you'll be fried in hot oil. Same way, some crabs are cooked live to have a better taste and better whatever, yeah. So, or else some of those dead crabs or damaged crabs which cannot be sold directly goes for animal feed, or unsaleable crab. This is another problem. And the processed crab into crab meat, another one. They generate your shells and other products, yeah. So crab byproducts are completely different as what a shrimp is, yeah. So again, what you do is whatever is unsellable crabs, that is again the whole crab is sold with the claws and everything, a leg is broken, a hand is broken, that is people they do not prefer because it looks like incomplete one. So those ones goes for recovering the meat, either for food purpose, feed purpose, or for pet food, and then you have a meat, frozen, pasteurized, or canned meat, yeah. These are the processed product. Same way, you have ingredients which can be used for making paste, pate, snacks, or cakes. A number of different products. This again goes to food science and nutrition science, or product development, or whatever you want to call it as, yeah. Now, when it comes to leftover shells from here, it's a very good source of chitin, chitosan, yeah. Every shell does not contain a chitin. That you'll figure it out when you do the experiment in 3 different matrices. So shells and harder part, you have minerals, you get proteins, enzymes, and other bioactives, including chitosan or polysaccharide, that's chitosan, or pigments, or crab flavor. You know, you can get all those liquid extract which will act as a stock solution or a flavoring solution, yeah. And if you see this many amount of this much amount of million tons or metric tons of crabs are left unsold because of different issues. I'll give you an example. Oversized, undersized potato. You go and buy potatoes. You don't worry about everything is small or a big. You just buy it, yeah. But in Europe, in certain countries including Ireland, oversized and undersized potato is a waste, yeah. People would like to buy a potato which are of uniform size, yeah. Big potatoes, very big potatoes goes to McDonald's and other places to make French fries, and some oversized, undersized potato which are graded are dumped as a waste, yeah. And that waste, to valorize it, now goes for starch production, and there again you have different waste. So waste depends upon what is the consumer requirement, yeah. That's why it says here unsaleable crabs, yeah. Nobody eats those claws and hands, yeah. They only eat the meat in it. The leg is not there, but at least the rest of the body is there, yeah. So they prefer to have intact crab to be purchased of premium price. So that depends how the processing is happening. So within this, again the same process applies to obtain chitosan, yeah. This is the practical what you will be carrying forward, yeah. So whatever we get here is again the wastewater, which can be used again for recovery of protein, minerals, and pigments. Once you recover this either by membrane or certain technique, leftover water can be used for duckweed cultivation, microalgae cultivation, or even macroalgae cultivation. So that water can be used, or it goes for wastewater treatment. So whelk shells, we already did discuss about the shrimp and a crab. Similar thing works for whelk. What is a whelk? Is snails. Yeah. What do you call that snails in your local language? Ghonga. I know the ghonga. Yeah. So that's same type of shells. Exactly same thing. Whole of the snails washed, cleaned, cooked in a water. Meat is recovered. Shell is a waste. Yeah. And then there also you get a wastewater. Yeah. And then this is some bit of statistics. So if you have 400,000, that is 4 lakhs. Yeah. 1000 tons of whelk are processed. 80,000 kg of meat is obtained, and tons of meat is obtained, and 320 kg, 320,000, that means 3 lakhs 20,000, yeah. When I say 100,000, that means 1 lakh, yeah. It's just because different units, million, billions, 100,000, we use lakh, crore, but that's 1 crore is 10 million, yeah, like that type of conversion. So 320,000 tons of shells, protein extraction by using enzymes, yeah. You can get 3.2 million tons of water with the protein rich fraction, that is 0.5 grams per liter, right. That is 0.05% of protein in that particular wastewater. So that goes as a waste, and you have dried shells, yeah. Now if you see, this is what statistics comes from the industry when they are processing it. So that's the problem what you have. So if you have this much amount of water in a year, having this much amount of protein, what you can do with that protein? Send this water to wastewater treatment, or else recover this protein. How we can recover this protein? Either by isoelectric precipitation, that is by adjusting the pH A, B by A is by precipitation, B is by drying all the water to get that protein, yeah. C step is to use a membrane, that is like reverse osmosis, ultrafiltration, nanofiltration. Use a membrane to trap that protein and get the clear water, yeah. And that clear water still will contain certain amino acids, broken proteins, another one. That means nitrogen, phosphorus, certain nutrients are there. That water can be used to grow duckweed or a microalgae, yeah. You create a new biomass, and then water can be discharged, yeah. Or D step is to send all this water to wastewater treatment, yeah. Your 4 different options are there, yeah. That's the way we establish circularity. That's the problem given here, yeah. What way you use this particular water? Remember, if you take a milk, yeah, 1 liter of milk will produce how much amount of cheese or paneer, dairy? 150 grams of cheese, yeah. So 1 liter makes 150 grams. What is leftover whey? Whey means leftover water. Wait 1 second.
750 grams.
750 grams. Take it 750 or 600 grams of of water is left over, yeah. That 750 ml of water contains some amount of protein in terms of 1% or 1.5%, yeah. And that particular protein is, that liquid is known as whey, yeah. And that particular whey protein isolate is sold in a market, yeah. Think, if we are talking about that much amount of solid, which is 1% or 2% or 0.5% solid, why we do not use this particular protein to be recovered from mussels and shells, yeah, even though the volume is high, yeah. You don't have to set up a €1,000,000 business to have tons of whey. You can have only for this particular sector, or even for a small processor who is processing 1000 kg per day or 1000 kg per week of a crab. Amount of water it is producing is dumping it. You have to put simple membrane system to recover the protein, dry it, and you sell it as a soup mix or make an ingredient out of it, yeah. Those who like fish, they also like salmon fish flavor, yeah, or crab or whelk. So this is the way how we can take translational approach. That means learning from dairy sector into this. Do you all agree with that? Yeah. So this is the way we can recover value out of waste. It's not only just talking about waste to value, apple pomage to pectin and some of the streams. That's the reason I'm picking up those examples which are easy to achieve and can be developed into. Yeah. So once we have this, you can recover both lipids and a protein and water for duckweed cultivation. And this water for duckweed cultivation can also be used for cultivation of microalgae or any other biomass. Yeah. So that is way we can obtain high value ingredients. And the lipids over here, they are always non-fatty or polyunsaturated fatty acid, although that will be in very, very small amount. Yeah. So that's the way we can convert those liquid processes. Now, so water, how important is the water for food? If you see, water between 2000 to 5000 liter is needed for everybody's food intake. Yeah. So this is roughly amount of water. This is not per day, obviously. Yeah. Amount of water required per day per person. And amount of fresh water is limited. And you need water for irrigation, livestock, application of your pesticide, washing, cooling, refreshing ingredients. Yeah. So do you know how much water you use in every day? So there is, if you calculate it, number of times you go to toilet, number of times you turn on a flush. One flush, there is a regulation. Yeah. It's 20 liter. The smaller one, if you press, the bigger one is normally 20 liters and smaller one is 40 liter, because people, they have a tendency to press always the bigger one if there are two switches. So always bigger one is 20 liter and smaller one is 40 liter. But over here, some of those tanks are 80 liters and 120 liters. Yeah. So that is one of the water usage. A. B. Drinking water is less, 3 to 5 liters. Water required for bathing and other things. Yeah. So water is required at every stage. Yeah. Correct. So that's water is very, very critical for sustainable food system. So we have to get a new way of water, either taking from ocean by desalination and all those processes, or try to restrict the usage of water in food processing operations, or to valorize the wastewater or processed water which is coming out of the food processing stream. Yeah. So you'll see two words interchangeably used, that is processed water and a wastewater. By processed water, what I mean in the subsequent sections is the water which is used to process the food, washing of fillets, using the water to extract the protein, that all will be processed water. That is all potable water. Wash water, washing of the floors, another one of the industry premises, that's a wastewater. Yeah. Now, so how we can make use of the water, how we can reduce the water usage? One is changing the production system. Yeah. And if water is not dealt with, we have changes in temperature, extreme weather events, and we need to have reusing of organic waste stream or wastewater treatment or water treatment options. Yeah. So this is what water scarcity is going to be a major factor in most of the country. Yeah. Because of changes in climate, undue rain and a flood. I'm not going to go into that one, just giving the importance of water in daily life, food production, food processing and different unit operations. Yeah. So if you see what is the type of water required for food production. Yeah. So when I said about we are going to valorize the nutrient from the wastewater or a processed water, at the end whatever water we are getting after production of duckweed, microalgae or seaweed, can we reuse that water into food processing system or in the food consumption scenario, or we can dump it into river. So this is all to do with the guidance note. If you go into FSAI, that is Food Safety Authority of Ireland, same way FSSAI is there for India. They have clear-cut demarcation, what is a potable water, what is drinking water, what is wastewater, what is strong water. Have you heard of this word called strong water? Rainwater quality, and all those water quality for different application is very well specified. So important one is from where the water is coming in, farming, runoff, grazing livestock into waterways. That means all the slurry of animals goes into the water. That means all the nitrogen is going into the river streams. Industry effluent discharged into waterway. All those factories are situated around the river. They dump their wastewater into river. Yeah. Urban wastewater treatment plant, effluent, private septic tank, badly constructed, leaking septic tanks. All these are the sources of water contamination into the groundwater. Livestock, pets, wild animal, access to the water sources. Yeah. So we do get our bottled water like this, but animals and pets, they have to go and take the water from river. Yeah. And the same animal is eaten. So if they are drinking contaminated water, or if you are harvesting the fish from the river for food purpose and you are contaminating the same river, so what will happen? You are getting your own nutrient contamination back to your body. Jaisi karni, waisi bharni. Yeah? Right? Simple. That's not, there is no rocket science there. If there is a meat processing plant, they use all the chlorinated water dumping into the sea and they are harvesting the same fish. So that is the circular economy of the contaminant for that same population. Yeah. So that is important thing to understand. So again, on-farm practices, storage of farm manure, slurry, soil amendment, disposal of pesticides, collection, storage and distribution of rainwater, nature private wells, and all these things are one which contaminate water apart from food processing operations or agri-food operations, how they are changing. So this is what when you assess the risk of water contamination. Yeah. So this is an important aspect to understand the requirement of water for food processing operations or for potable water and how we can assess risk. Yeah. Now, so what are the water treatment options? How we can treat the water? Simple one is adding the chlorine. Yeah. Chlorination is done at a treatment point at very high concentration. By the time it reaches at domestic level, water chlorine level is low. So we are consuming lot of chlorine as a form of water treatment. So you have coagulation, flocculation, sedimentation, filtration, disinfection using chlorine, chlorine dioxide, ozone or UV light. Yeah. These all are treatment system for water. I am not again going to go into that part, and the similar approach can also be used to treat the water whichever is left over from the food processing operations, so that that water can be reused within the same industry premises, or the processed water which is used extensively can be used for cleaning of the water, right? There is a potable water is required, and if the water is of not that standard quality which can be discharged into the river, or that water can be used for the cleaning purposes. Some of those standard practices are smart designs. That means whatever you have your flush, that is always linked with your wash basin. So water is collected there with the filtration. That means only solid is going away, right? So why always to have a fresh water for your wash basin and the same fresh water for flushing water? Make sense? Yeah. So that every small changes makes lot of difference. There used to be old advertisement, what is called "Boond Boond Bachana Hai." Yeah, right? Do you know about that advertisement? There used to be advertisement like you have to save every drop of water like this. Yeah. So safety and a quality of water used for fresh fruits and vegetable. Yeah. So that will give you all the guidelines. This is again, as you see the table 2 coming in from this particular document, and whatever is referenced in any of this presentation is freely available. That means either the papers are open access or they are in FAO document which is universally adopted. I'm not focusing entirely only on a country specific or European document, but pretty much the regulations are similar. Yeah, okay. So that's what it says: pre-treatment, coagulation, different water treatment system. I'll propose one way. If you are using a brine, yeah, and we can reuse this brine by using a membrane system to recover all the solid, even the simple filtration system, and then use any of these techniques to decontaminate that brine and reuse that brine. Yeah, that's the way it can be used. If you know some of those people who make paneer at home, whatever water is left over after using tartaric acid or your citric acid or lemon or whatever, the same water can be used again for next stage of curdling process. But at house is okay, you have plenty of lemon, but you're talking about the quantity that makes things easier. Yeah. So that's the way how we can reuse it. So the crux of this is all to do with innovation. Yeah. That is innovative idea to use it. Now, process water valorization. We started with aquaculture for solid stream. Similar thing is aquaculture production. Whatever wastewater is there in aquaculture which is happening in the sea or in a pond system, if we can use the same water for growth of macroalgae. Yeah, this is macroalgae, that is Escargopsis. And if you look at this particular species, this is one of the important species which has been seen as reduction of methane emissions in cow. Have you seen when there is a big bloating in cow, you have to put a syringe so that all the methane comes out of a cow? Yeah, because that is a huge impact on animal intensive agriculture, where methane emission coming from bovine animals is contributing to methane in environment. Yeah. So this is used as a feed additive because of bromoform, yeah, which is added as an animal diet to reduce the methane emission from bovine animals. Or vulva, that is again a green seaweed, which is good source of protein to recover the nutrient from wastewater. Or similar one can be used for duckweed. The only example here macroalgae is given because this particular water is from marine source and these seaweeds grow only in marine environment. Yeah. Duckweed is mainly fresh water and some are salt tolerant. So there is again species selection is. Then we have new technologies or different type of processing approach to create a value chain for feed or a food, leftover biomass for energy. Yeah. This is one is a blueprint how we can use processed water for valorization. Yeah. Then another technique, if you see, coming back to the fish, once aquaculture fish is processed, you have a whole fish. This is pretty much the process line for fish. Yeah. Your whole fish, you wash it, you freeze it, you thaw it, you do filleting and you get your food product, right? Simple process. Or else you have a whole fish, you can put any species, mackerel, this line, salmon, this line, sardines, tuna, this line. Yeah. Fish is washed, you put in a brine solution, you steam it, you put in a can and you get your protein rich food. Yeah. So this is what I have written as a protein rich food because fish is considered as good source of protein. Now, what happened in this process? The water coming out, the whole fish when you are washing it, you have all your mud and everything on top of the fish. Yeah, that is called stick water. That is mud water, another thing. Washing of the fillet, you have wash water. Yeah, and water used here is a potable water. You are using a brine, then you have leftover brine, or you have wastewater along with the steam. When you steam the fish, water collected that also solubilize some of the protein. So this is the estimates which can contain, if you are using 5% salt as a brine solution, you can have 10 to 12% protein in that particular water. If you are using a steam, 5 to 8%. If you are using only water, you get only 1 to 3% protein. Yeah. These values can vary depending upon your intensity and the process. You are making a thick fillet, this may be less. If you are making a thinner, wafer thin fillets, then it's a different story. Yeah. So that will be just rough estimates. Yeah. And if this particular water, this is just representation of the water which was collected from the wash factory. Use a membrane, you spray dry it or you freeze dry, you get your protein. Yeah. Simple process. You don't need to know about rocket science to develop this process. Yeah. Stick water, high amount of BOD, COD because muds and sludge and everything that goes for wastewater treatment can go as usual as a wastewater treatment. If you mix this water with this water, then story is different. Then you cannot use this as a food ingredient. Yeah. Whereas this is a process water and this is wastewater. Yeah. And then if you see ultrafiltration, salt brine, ultrafiltration, retentate and permeate. That is something like when you are saving, you have retentate and a permeate, two fractions, and amount of protein distributed in different fractions. That means if you are using ultrafiltration at molecular level, normal brine solution, if it contains 10.6 milligram per ml, ultrafiltration or 100%, and then 90% protein can be recovered by using ultrafiltration itself. That goes straight for spray drying, you get a protein. And a rough estimate is every 100 kg of sardines, we need how many meter cube of water, yeah, and how many meter cubes of cubic meter of water is used, and what is the protein content you can obtain from that water, and lipids. Think of the volume of several thousand tons of fish processed globally. Even if you take a specific district, take it even Cuttack in Orissa or Calcutta, or if you take it in Chennai, Kanyakumari or Kerala, any of those districts, within that place itself, amount of fish is processed and amount of water it will generate and what is happening to it. Yeah. So you can consider the business case and how economical it will be. Yeah. Now, this is another one, fish processing plant, different wash water. This is having more specific details. Previous one was on a bigger figure, and as scientists they have a tendency to complicate things, so this I have a bit complicated with what you get out of it. Yeah. Fish processing operations and fish value added product. You have nitrate, nitrites, ammonia, lipids, nutrient, phosphoric acid, nitric acid, other contaminant, all this effluent. If you try to check the composition of the process wastewater or process water or wastewater, you have total nitrates, total phosphorus, total potassium in different forms, you get it, right? If you have seen the water report, nitrate, nitrite, phosphate, everything out of it. Yeah. Wastewater with high level content of blood and contaminants, wastewater with less amount of blood depending upon what type of fish is processed, or wastewater with contaminant. So before you start valorization strategy for a wastewater, you need to understand what are the contaminants in a water, what is the condition of that water before you start extracting. Yeah. And then all these nutrients, whatever is there, then you decide whether you want to propose a system to grow macroalgae, microalgae, duckweed, or any other plant which can absorb these nutrients at what rate. Yeah. It is not that since I said you grow duckweed that you only grow duckweed. You can go for microalgae or you can go for other plant, that is biological way of remediation, and then phyto, that is plants for remediating wastewater, is one of those microalgae, because microalgae have a tendency to grow on high nitrogen, low nitrogen, high phosphorus, low CO2, high CO2 or different oxygen. That depends upon the species. Then you harvest your cells and you get your different nutrient. the crux of this particular flow diagram is to use inorganic nutrients into organic, yeah. Because if you, from where we get these acids? Because certain processes, you know, when you're using chlorinated compound, acid extraction, or this also includes, you know, extraction processes. When you are going to extract the protein from fish or from chitin from shell, you will be using acids and alkali. That will be altering the pH. Accordingly, you can select what biomass to grow. So, we already discussed this one in day 1, conventional wastewater treatment system, right? All the wastewater, this is the image of that, it's energy intensive, huge amount of resources are required, and then the issues with sludge removal, right? Now, if you look at this proposed solution, yeah. Now, when you see this word phytotowel, this was a team of 2 master student and a PhD and 1 final year undergrad student. They came up with one of the idea to use the wastewater valorization that is added in next couple of slides. The proposed model was, because soybean is imported as a protein from Latin America and it's having huge amount of issues with the climate and other things, because Europe or certain countries cannot produce soya protein, which is used for animal feed, yeah. And then the wastewater coming from dairy is mainly nutrient rich, yeah. And I can say this specific example of dairy was added because a lot of dairy technologists were coming in here as well, yeah. And then you have dairy processing plant, this wastewater, this is the proposed phytotowel, that means to grow duckweed. You get a clean water, you get a biomass which will be covering in duckweed production. You'll see how it is cultivated. You dry it, and this is the best source of protein which can be used for the same animal which is producing that wastewater, yeah. Does it make sense? Or any questions you have? It looks so rosy, you know, to draw the process on a paper. When you start doing it, then its problem starts, yeah. So, this is one of the project called duck feed. That means how we use the wastewater from different sector to produce duckweed. And if you'll see different species, Wolfia, yeah, origin, which country? That means doubling time 1.3. That means if today biomass is 10 grams, in 1.3 days the biomass will become 20 grams, yeah. So, and this is the composition of dairy processing wastewater, high amount of BOD, COD, and the water to be discharged in a river is having a limit. You cannot discharge the water having more than 100 BOD or COD, yeah. So, you don't have to completely eliminate all the organic matter. You can partially eliminate matter, and this is the way how duckweed grows. And we will be covering this one in detail when we go into duckweed production, and I'll show you some of those live examples. Water, instead discharging, goes for duckweed cultivation, very similar type of tank, and you get a protein powder. And this duckweed contains almost 30 to 35% protein on dry basis. Moisture content over 90%. It is a floating plant on the surfaces. How many of you have seen the lake with these green plants? Yeah? You have seen most of the lakes are always green, and they have one of those jetting system to collect all this thing and cleaning it, yeah? So basically, if that discharge water is going into river, you design a system, even open pond system or in a tubular system, which grows duckweed within that. It will look nice, it will give a greener appeal, and then to discharge the water, and that's a perfect biomass, yeah. If you do a controlled production, or you can call it a controlled crime, that is organized crime or disorganized crime, yeah. So that means how you can produce duckweed. This is the strategy for water. And now this is the figure. It shows what is the growth rate and crude protein content compared to oats, soybean, barley, maize, sorghum and duckweed. That means amount of protein produced per unit of land. If you have 1 hectare of land, how much plant protein can be produced in a year? Yeah, you can take 2 crops or whatever. Whereas if you have that much amount of land, how much duckweed protein you can produce? Yeah. Here, White is not talking about the food protein alone, but for feed protein. But if you look into the literature, duckweed is used extensively for human food application and is grown on the clean water for human food in Southeast Asia, and it has been already gained approval for human food application and commercially cultivated in America and certain countries in Europe. In Asia, India, we do not do that consumption production at the moment. Whereas in China, Southeast Asia, this is carried out, and Israel is another country who does extensively this duckweed production. Yeah. So this is quite complicated matrix. Yeah. And now this is being calculated based on seafood. 1. Whatever side streams we get, what is it? Processed water and solid side stream, right? Solid side stream, what we can obtain? Protein, chitin and other nutrients. Yeah. If this protein, fish meal, fish protein concentrate, isolate and hydrosolate, considering 40% of solid waste is used as protein rich meal, and this is amount of tons of protein which can be recovered from the European seafood production. Yeah. Chitin, considering 15% of solid waste and 20% chitin purity. Yeah. Based on whatever process we do without using any new technique. Collagen, gelatin, hydroxyapatite. Other day I was talking to you about hydroxyapatite or minerals which can be obtained. Is it readable from there? Yeah. That's good. And then when it comes to processed water, protein, assume 7%, considering wash water for fillet, steaming, brining, mussels cook water, well cooked water, everything take an average of 7. Minerals, 2.5% weight by volume. Residual water, if you remove 70% of protein and 60% mineral recovery and other nutrients. Yeah. Now, when you recover some of those nutrients, and if you recover the protein based on the water usage, this is the ton of the protein what you can obtain is calculated based on 70% of protein recovery, which can replace 50% of soya protein which is imported from other countries into Europe. Yeah. This is just showing the business case how it can operate if we valorize the waste. So whatever we discuss, the implication of waste on greenhouse gas emissions or for dumping it, how this is, or how we can recover nutrient and what is the value of it. Recovered minerals, yeah, this many tons, considering 60% mineral. Collagen, gelatin, hydroxyapatite, again same thing from processed water, that also will contain some amount of protein which is having minerals and other element. We can obtain this type of ingredient. And very similar approach can be adopted for any given state in the country or whole of India. You know how much seafood is processed, what are the side streams obtained, whatever processes of recovery are there, different unit operations, and you can design this full strategy. Now, if this wastewater, residual water, is used for duckweed production alone, this much ton of biomass you can produce, this much ton of protein, and the protein will have 15% replacement of soya protein, at the same time solving your environmental issues. Yeah. Other one, microalgae production, this is calculated only for cholera vulgaris biomass. This much ton of cholera vulgaris biomass can be produced based on this particular wastewater. And the protein which we can obtain, if you take simple protein extraction process which is 60% efficient, there how much protein we can obtain, yeah. So any of those ingredients, any of those ingredient using these processes to produce another biomass, we can have a fish feed to feed it to fish, because when you grow fish they need a feed. You make duckweed or microalgae to make a vegan product. Somebody is working on vegan meat product and vegan fish product, and same duckweed and microalgae or macroalgae will have similar smell as a fish. That is a perfect product for making vegan or meat alternative. Or same, this protein goes for non-vegan product, or chitosan or collagen can be used for making biodegradable packaging, yeah. So this was the crux of your solid waste and liquid waste, how this system can be generated, yeah. So this is like a city map. But this, like a Rome was not built in a day, same way to achieve this you cannot do it in one go. You need to have optimization to make duckweed production. Multiple number of theses and research has been carried out. Multiple number of theses will be covered to produce the microalgae, selection of species and all those things. Half of the work is already there in literature. You have to pick the best condition. Some of your colleagues and people are working on to the making of products out of it. Some are working on extractions, yeah. So all those informations comes together and to make a full process line, yeah. You can put any specific material to it, yeah. And if you have to simulate it, this is based on, actually this should have been based on 100 kg, but this is on actual value. 100 kg, how much you can obtain, yeah. And then you can change the biomass and you can make this particular process, yeah. So I have been told to provide one assignment for you which will be evaluated. So you will have to develop this type of scenario, yeah, and just put a reference to it, yeah, how much you can obtain different ingredients out of it, yeah. So you can take a biomass of fish, yeah, A, B, you can have your dairy, yeah, C, based on your choice, yeah. I don't want to make non-vegetarian vegetarian, vegetarian as a non-vegetarian. Whatever is your choice of a crop, you can make a list of it. I can hand over to Ganga or to him and then complete your assignment, yeah. It's not difficult, it's very, very easy assignment. But whatever you are picking, you have to put a justification to it, yeah. Or what is the source which shows how much protein it can be obtained, or what is the process, yeah. Yeah. Is it easily done? So this was the valorization of liquid. So what did we study? What are the solid side stream, the liquid side stream? What are the valorization strategies, yeah. Now I'll quickly go through this particular duckweed production maybe in the next lecture. So if you have your wastewater and if you have your process water and you have your solid side streams, yeah. Do you have any question related to this, how you can process it or how you can valorize it? Or if you have any suggestion, are you more confused? Because as we go along, confusion level might increase, yeah. Because there is a lot of thinking process what you guys have to do to establish the processes. This is a bigger picture and specific processes for extraction of proteins protein extraction, lipid extraction, chitin, chitosan, minerals, all these things will be specifically covered on how we extract those. Yeah. Any questions?
Sir, I have a very simple query. With this previous things, the end thing is the duckweed. It is coming as a feed, which is in place of soy. We will go for the cattle feed. My simple query is that if it is having right now you included that it will be used for the vegan fish product as well, we can like that product. We know how the fish has a smell similar to that, it will be having a smell, but do the cattles will they eat that kind of smell if that is carrying the duck?
No, they do, because actually that's a very valid question. And here duckweed is used as a source of protein. That means you obtain a protein from duckweed. And duckweed, which we'll cover in the next lecture, duckweed production system. Duckweed basically contains majority of the water soluble protein called rubisco, like a green grass. It's having a cellulose, starch and everything. So that protein is extracted and it is consumed. A. Second one, it's duckweed itself will not have a fishy smell. Yeah, that is used as a feed. So that means then you have your, again, veterinarians are required to do the feed formulation, because feed formulation is equally complicated than as a food, because feed should have not only the protein is the major ingredient, plus you have all of the minerals and nutrients are added in to make a animal feed. Yeah. So that is that's another question which is used for feeding purpose. A. B. Duckweed also, if it is not for animal feed, it is also for fish feed, which the fish automatically they consume in the water when those type of aquatic plants are growing. Yeah, because we don't feed anything in the ocean, do we? In river, fish is there, what they get a food from? All the small plants, small insects and all those things growing around. Yeah, this is the purpose how we can solve the two problems. One is the environment one, to valorize the wastewater and recover that nitrogen, which is at the end of the day is going to go into this form of sludge, adding to the landfill or go into the river water and disturbs the ecosystem. This whole story is balancing between three E's. What were the three E's? Economy, environment and ecosystem. Yeah. So these are the questions what you need to answer, and that's very valid question. Yeah, I can propose what you should eat, what will be healthy. Yeah, what you will eat based on your own choices. Yeah, even if I know egg is very healthy, being a vegetarian, I won't eat it. Yeah, so there it comes social aspect. Yeah, right. So that's why we all are different. Everybody's having different eating habits, and if everybody's want to eat only the same type of food, then it's a problem. Yeah. So we all have different eating habit because all are different. That's the saying, all 5 fingers are of different sizes. If all 5 fingers are of the same size, we can't do any job, right?
Firstly, you sir, you give the recap of the yesterday class. After that, you explain just example of shrimp culture. After that, solid क्या था? Solid side
Solid side streams. Yeah.
Yes, sir. Solid side stream valorization, liquid side valorization, and after that give the example of fish culture and how to estimate different proteins and lipids, and overall introduction of overall the map idea of the research, like sir, how to produce from substrate to like production level, and how to consume, and
Okay.
yes.
That's good. So at least I can say 10% success is there anyway. Yeah. So that's good. So basically, again, what the solid side stream and liquid side stream, what are the biomasses? Yeah. And if you are interested in having a specific a research paper, not research, review paper which clearly explain all those things, I can easily provide you with. Yeah. And any of the questions, if you cannot ask here, you can ask after, and whenever we have interaction, you can ask all those questions, how we can grow microalgae and duckweed, because it will be difficult to do all the practicals of growth in, but we have carried out that. You will see that example from the duckweed itself. At the end, when you see the phytotowel one, was a project, the BSIC, Bioeconomy Student Innovation Challenge, that was done at European level. Every country was sending one team. One team went from Ireland, and they got second prize for this particular concept. Yeah, and this concept is not rocket science, and that was carried out by one PhD. Her PhD was on the food processing, on macroalgae production and valorization, where her basic degree was in entomology, completely different area. Bachelor's in zoology, master's in entomology, and PhD on food production. Yeah. So that means food science is not a domain of a specific food scientist. If you think we have done BSc food science, MSc food science will do wonders there. That's not always true. Yeah. So it's all again how you think about a different area and club it together with a process. That one you will see, which will make you more innovative way of thinking how we can produce a duckweed. And the duckweed was grown in a lab, and then if you go fine tuning of improving the performance or improving the production efficiency, that comes secondary. Yeah. So that's great. If you don't have any questions, so we'll close it at this point, and we'll meet again for the next lecture.